Hey guys, this is my first video Special Theory of Relativity, which will consist of some of the aspects to understand the basics of STR. And if you want to download this PDF of short notes, the link is given in the description. So let's dive into it. Reference frame. What is a reference frame? A system of coordinate axes which defines the position of a particle or an event in 2 or 3 dimensions. Now, what does that basically mean? Let us take Cartesian coordinates x, y, and z axis with O as origin, and let us take a point object A with coordinates x, y, and z. Now, this Cartesian coordinate is a reference frame because it tells us the position of particle A. There are two types of reference frames. First of all is inertial frame of reference. This is a type of reference frame which neither has a linear acceleration nor is undergoing any rotation. That means it is either moving in a straight line with a constant velocity or is stationary with respect to another reference frame. Now, second one is non-inertial frame of reference. This is a type of reference frame undergoing either a linear acceleration or rotation or both. Now, why do we need to categorize reference frames like this? This is because Newton's laws of motion are consistent only in inertial frames of reference. This is a very important statement that we need to understand properly because most people just remember the statement and ignore its true significance. Let's take a stationary box, and inside the box there is a particle accelerating with acceleration A due to a force F with respect to the box. We want to test whether Newton's second law, F equals to ma, holds true or not. Since the box is itself stationary with respect to surroundings, F would be equal to ma inside and outside the box. So it does not matter where you are, F would be equal to ma. Let the box now move with a constant velocity v with respect to the surroundings. Now, it matters where you are, inside or outside the box. If you are inside the box, you will also be moving with the box, whereas outside you may be standing still. You may also be moving outside, but for the sake of the simplicity, let us say that from here on, if you are standing outside, you are stationary with respect to the surroundings. Inside, you will see that F equals to ma, and from outside also, F would be equal to ma. The box and the surroundings are two inertial frames of reference, and Newton's laws are consistent in both frames. Let the box now move with a constant acceleration a naught. Again, if you are outside, you are stationary with respect to the surroundings. However, here things change. Here, from inside the box, F would be equal to ma, but outside, F is not equal to ma, since from the perspective of outside, the particle has two accelerations, a naught from the box and a, its own acceleration. So, the consistency of laws of motion does not hold in this case because from outside perspective we would see the force F giving an acceleration a naught plus a, which is more than a. Similarly, if the box was rotating, the consistency would fail. There is a simple fix for non-inertial frames which we will see in mechanics. From now on, we will only be talking about inertial frames of reference. Galilean Transformation. We have been dealing with this transformation ever since we studied the laws of motion, so I'm not going to go into detail here. Here are two frames of reference S and S dash, where S is stationary frame and S dash is moving with respect to S frame with a velocity v. And here are the transformation rules. Galilean transformation works when the velocities under consideration are small, much smaller than speed of light. Why? I'll explain them later, but first I'll tell you something about ether hypothesis and Michelson-Morley experiment. Ether hypothesis is an analogy between light and sound propagation. According to this hypothesis, EM waves propagate through a medium called ether. Before 1887, scientists hypothesized that there is a material present throughout the universe called ether, which acts as a medium for propagation of light, just like sound requiring a medium to propagate. This hypothesis was tested in 1887 in Michelson-Morley experiment using Michelson interferometer. The existence of ether would imply that EM waves in moving reference systems propagate with distinct velocities in the forward and perpendicular directions. This comes as a direct result of Galilean transformation. To understand this, let's say that a spaceship is traveling with speed of c by 2 with respect to an observer, where c is the speed of light, and the observer is positioned at O. It ejects two beams of light, one in the direction of its motion and other in the direction perpendicular to its motion. Now, if ether hypothesis was correct, the observer would measure the velocity of beam 1 to be 3c by 2 and the velocity of beam 2 to be 1.118 c. It can be easily calculated by trigonometry. What actually happens, we will see in the moment. According to the hypothesis, it was expected that the speed of light would change because of Earth's revolution around the Sun and would vary in different directions as we saw before. But the experiment proved that light propagates with equal velocities in all directions along the Earth's orbit and perpendicular to it. This is like saying that velocity of both beams 1 and 2 according to the observer is c. This means that light does not require a medium to travel. Light can propagate through vacuum, and its speed in vacuum is a constant and is a fundamental property of the universe. For inertial frames, when objects travel with relativistic speeds, that is comparable to speed of light, space contracts and time expands such that speed of light in all inertial frames of reference is constant no matter where the measurement is made. This gives rise to special theory of relativity, which will be discussed in the next video.